This is R.D. Sharma solution, class 12th, chapter 11. Differentiation exercise is 11.2. The next question is, so the normal version of this type of question we have already done. And how to prove that it has some expression coming out of it with a dy by dx inside it. That's what we have to see. So in order to have a reference how to write, I've given you the solution. But those who actually want to see how the question is being done, dy by dx, the numerator here, the numerator and denominator I am indicating, assuming it to be u and v, the quotient rule has to be applied. But since in the numerator we have x sine inverse x, that transpires to be a product rule solution. Alright. So let us see. First the denominator will be the square of whatever is in the denominator. So under root 1 minus x square, it will be 1 minus x square only. So this is the denominator we have. Then under root 1 minus x square will be here. Under root 1 minus x square it will be. Please remember, this d by dx it will come here. On the right it will be x plus y by x. So we have to be very vigilant how we are solving it. We cannot cancel things out. We have to see what the solution wants. Now d by dx of x sine inverse x, that will be performing with the product rule. Then x sine inverse x in the front and d by dx of under root 1 minus x square. So anything with the root will be 1 by twice of under root of that thing. So we will just write it like this, 1 by twice of under root 1 minus x square. Okay. So 1 by twice of under root 1 minus x square, then we'll do the differentiation of 1 minus x square, that is going to be minus 2x. So 2 gets cancelled. Finally, the differentiation of under root 1 minus x square will be negative of x by under root 1 minus x square. So minus I took it as plus, and x by under root 1 minus x square I am writing. Alright. Now, x sine inverse x we have to differentiate it. And that will be done by the product rule. So let us see now. X sine inverse x, we will apply the product rule. So first x, then d by dx of sine inverse x. Then we have the sine inverse x and d by dx of x. So x sine inverse x is 1 by under root 1 minus x square. And then we have plus sine inverse x and d by dx of x will be 1. So I am not writing it, it will be just 1. Alright. So what we are going to write final here is under root 1 minus x square into x by under root 1 minus x square. Then we have plus sine inverse x, and then we have plus, so this x and x will become what? X square sine inverse x divided by under root 1 minus x square. I am doing the numerator only. Denominator I haven't written up till now. So now multiply this inside. Let us multiply this inside. And x under root x square will get cancelled. X plus sine inverse x into under root 1 minus x square plus x square sine inverse x divided by under root 1 minus x square. Up till here we have reached. So sine inverse x and sine inverse x are here. So let us take the LCM. Now please remember always a by b plus c by d. If we don't know how to find out the LCM, then how do? We multiply a with d, so ad plus b into c, and then in the denominator we have b into d. Okay. So let us multiply this. Under root will get cancelled. So x plus 1 minus x square sine inverse x will remain here. Now multiply these two. 1 into x square sine inverse x. So it will be x square sine inverse x. And in the denominator, we are going to get under root 1 minus x square. This is okay? and this is dy by dx. Now remember, denominator we already have 1 minus x square, the point we started. This 1 minus x square I am talking about, and this whole was only the upstairs, and that means the upper part, numerator I was taking. Denominator, I haven't written 1 minus x square, so that will always be in the denominator, dy by dx. So this we can take on the left hand side. Okay. So this all right on the right, what we can do, because we have to find out the answer also. Now I am opening it. That means this, let me tell you again, 1 minus x square I haven't written anywhere in the denominator, so it goes on the left. It was already there. And then we have this as sine inverse x minus x square sine inverse x plus x square sine inverse x. I am multiplying 1 minus x square with sine inverse x. So the x square sine inverse x gets cancelled. It will be x plus sine inverse x divided by under root 1 minus x square. That will be. Now this whole, if I write just like this, x I can take on the left hand side. So y by x is actually equal to sine inverse x divided by under root 1 minus x square. So in place of that, you can write y by x. So on the left, what we have, 1 minus x square divided by into what dy by dx is equal to x plus y by x, and that was the final result. Now y is equal to e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Dy by dx has to be proven to be 1 minus y square. So there are different methods, different trials can be done, because we have done already a question like that. You can write e to the power minus x at 1 by e to the power x. So you will get e to the power 2x minus 1 divided by e to the power x. And in the denominator, you can have e to the power 2x plus 1 divided by e to the power x. This gets cancelled. So e to the power 2x minus 1 divided by e to the power 2x plus 1. That is the final, and that will make the transition and the solution easier. Okay. So that's just the thing which will make it easier to solve. But in a normal way, in a way which we normally solve, the step-by-step thing, let us take this dy by dx we are going to take, and we'll just take it as numerator denominator, and we'll apply the quotient rule. So we have denominator square e to the power x plus e to the power minus x whole square. Then we have e to the power x plus e to the power minus x here, and d by dx of e to the power x minus e to the power minus x minus e to the power x minus e to the power minus x, and d by dx of what? E to the power x plus e to the power minus x. Now let us do the differentiation first. In the denominator, this is already there, and we will just reformulate it, and you will see that this becomes so easy after differentiation. So I am differentiating these two, which are the arrows are indicating. So e to the power x, e to the power minus x is e to the power minus x only, but differentiation of minus x will be minus 1. So a negative will come outside. Alright. There will be a negative coming out. So it will be e to the power x plus e to the power minus x. Here you have e to the power x, and e to the power minus x will be e to the power minus x. Again a negative will come outside. So this will be e to the power x minus e raised minus x. Now since these two terms are same, so it will be simply square e raised x plus e raised minus x whole square. Alright. So let me write it as ex plus e raised minus x whole square. This also e raised x minus e raised minus x whole square. So if you want to open it up, that is a plus b whole square formula, there will be cancellation of twice of e to the power x plus e to the power minus x. But that is not going to resolve our issue, because we have to see what we have to prove also. What we can do is we can separate these two terms with respect to the denominator. That is e raised x plus e raised minus x square divided by e raised x plus e raised minus x whole square minus numerator we have e raised x minus e raised minus x whole square divided by e raised x plus e raised minus x whole square. Denominator remains the same. Now this gets cancelled. First term 1 minus, okay, this is what? Y. E raised x minus e raised minus x divided by e raised x plus e raised minus x is y only. So this one is y square only. This is y square. On the left side, what do you get? Initially we started with dy by dx only. So this dy by dx is equal to 1 minus y square. This is how you can match the answer also, but you have to write in a way I gave you the answer, the printed one. Now we have to prove that dy by dx is equal to log x minus 1 by x plus 1. So assume it to be 1 plus x, it is given. Just, normally the questions have some certain way we presented, like 1 plus x it is. It is not like, it is just x minus 1 by x plus 1. So this is the answer I am providing you. You have to write exactly like that. We have differentiate with respect to x, wherever you apply the chain rule or the product rule or the quotient rule, everything you have to write there. Because examiner knows everything. It is for you to know, and you have to tell examiner that I know this thing. So you have to write and present it. You have to show it in ink, written form. Okay, x minus 1 log x minus 1 minus x plus 1 log x plus 1 d by dx of this. This again d by dx, and then we will just subtract these two. So first term, second term, there are two terms with a subtraction sign. First term will apply the differentiation with respect to and with employing the product rule. So x minus 1 d by dx of log x minus 1. Then we have minus, plus it will be, plus log x minus 1 and d by dx of x minus 1. First I am doing this one only. So x minus 1, log of anything, differentiation is 1 by that thing. So it will be 1 by x minus 1. And x minus 1 differentiation is what? X differentiation is 1. 1 differentiation is 0. So it will be 1 only. And this is going to be 1 only. I am not writing it. Now log x minus 1 d by dx of x minus 1, as we just saw what it will be. It will be 1 only. So x minus 1 gets cancelled. 1 plus log x minus 1 it will be. Now I am doing the differentiation of the second part, second term basically after negative. So let us change the color so that you understand I am doing the second part. X plus 1 and d by dx of, I am applying the product rule. D by dx of log x plus 1 and plus log x plus 1 now and d by dx of x plus 1 now. Okay. So dx plus 1 log is 1 by x plus 1. X plus 1 is 1 only. Here log x plus 1 and log d by dx of x plus 1 is 1 only. So this gets cancelled. You have a 1 here only. 1 plus log x plus 1. Now the first was 1 plus log x minus 1. This one. If this is A, this is B. The differentiation of A is this one. The differentiation of B is this one. Now we have to apply A minus B. So I am writing minus 1 minus log x plus 1. 1 gets cancelled. You will get log x minus 1 minus log x plus 1. So log x minus 1 minus log x plus 1. This is log A minus log B. So when we have log A minus log B, it will be log A by B. Log A minus log B is log A by B. So it will be log x minus 1 by x plus 1, and this is equal to dy by dx. Alright? And that is what we have to prove. Next one is y is equal to e raise x cos x. Dy by dx is under root e raise x cos x plus pi by 4. Now how did this pi by 4 has come? For that we have to do certain multiplying and division in one of the step. That is the whole idea of this question. So the basic idea is to differentiate. We have two terms, e raise x and cos x. So we'll apply the product rule. So e raise x d by dx of cos x plus cos x d by dx of e to the power x. E to the power x, cos x is minus sin x. So minus ex sin x, cos x here, e to the power x will be e to the power x. So I am taking e to the power x common and I am swapping the term so that I get a negative in between. It will be cos x minus sin x. E raise x, cos x minus sin x. Now multiplying root 2 here and here. So I am introducing 1 by root 2 with cos x, 1 by root 2 with sin x. So when we introduce 1 by root 2, root 2 has to be multiplied also. So cos pi by 4 is what? Cos 45 degree. Cos 45 degree is what? It is 1 by root 2. So this 1 by root 2 has been introduced just because of that. So cos pi by 4, in place of 1 by root 2 you can write cos pi by 4. In place of 1 by root 2 you can write sin pi by 4, because sin pi by 4 is sin 45 degree and sin 45 degree is nothing but 1 by root 2. So cos pi by 4 cos x minus sin pi by 4 sin x, and in front you have root 2 into e to the power x. So this cos x, if you just consider it to be the first term, so cos x cos pi by 4 plus sin x sin pi by 4 is cos x plus pi by 4, cos a plus b. This is the formula of cos a plus b. So root 2 e to the power x cos x. So d by dx, dy by dx of this is root 2 e to the power x cos x plus pi by 4. If y is equal to half log of this term, we have to prove dy by dx is equal to twice of cosec 2x. So we have seen the trigonometric solution, differentiating it in different ways. So half is already there. The question might have been under root of this thing. This type of question can come. So just consider taking this half or any of the power inside the root term, log term with a root or whichever power. This power has to come in front. Now 1 minus cos 2x, with the trigonometric knowledge we know that this is 2 sin square theta. 2 cos square theta is 1 plus cos 2 theta. So 1 minus cos theta is 2 sin square theta, 1 plus cos 2 theta is 2 cos square theta. So in place of 1 minus cos 2x, just write 2 sin square theta. In place of 1 plus cos 2 theta, you can write 2 cos square theta. Log is already there. Half is already there. So I am not differentiating it, I am trying to simplify it. So you have log sin square theta by cos square theta, that is tan square theta. Now when we have a power with log, this power comes in front. So this 2 has to be taken in front. So 2 by 2 gets cancelled. You get log tan theta. So y equals log tan x. This is what you have to differentiate now. So the simplification have been done using all the knowledge we have with respect to the trigonometry. Log x is 1 by that thing. So 1 by tan x is sec square x. Now sec square x and tan x we can write in terms of sin cos. Tan x is sin x by cos x. Cos goes up. And this sec square is 1 by cos square x. So this cos gets cancelled. 1 by sin x cos x. Twice in the denominator, twice in the numerator. I have introduced it. 2 sin theta cos theta is sin 2 theta. 2 by, this is going to be sin 2x. So when it goes up, it will be cosec 2x. 2 was already there. Sin goes up, it will be twice of cosec 2x. And this is simply dy by dx. Alright. So this is what have to be proved, and we have proven it. Okay, this one we will be taking in the next discussion. Till then, thank you so much and take care of yourself.